Our next lesson is called Multiplying and Factoring Polynomial Expressions, Day 1. I'd like you to start with the opening exercise. It says write expressions for the areas of the two rectangles in the figures given below. Then underneath, now write an expression for the area of this rectangle. Please pause the video, try the opening exercise, and resume when you're ready to go over your answers. Okay, so now that you've had time to go over it, let's take a quick look at the answers. When you're finding the area, you're going to multiply your length and your width. So 2z times z is 2z squared. 2z times 8 is 16z. Notice that these are exactly the same. Okay, those widths are the same. Now write an expression for the area of this rectangle. What they've done is take the blue and the orange and push them together to make one large rectangle. So to show the area of that, we're going to take the area of the blue and the area of the orange and add them together. So you would have 2z squared plus 16z. Now, using this kind of as a guide, we're going to look at example 1. The total area of this rectangle is represented by 3a squared plus 3a. Find expressions for the dimensions of the total rectangle. So I'm going to model like what we did in the opening exercise, and I'm going to break this up in pieces. And we want to think about what's common to both of those parts of your expression, just like you would have done up here. So the side that we want the width is going to be 3a. That's common to both. And now we want to think what we would have to put on top to get 3a squared and 3a. So if I have 3a here, and I know I want 3a squared inside here, I would have to multiply this by an a on top. If 3a is on the side, and I know I want 3a on the inside here as my area, then I know I'm going to need to multiply by 1 on the top. So now I know that this is equivalent to 3a times a plus 1. This part of the expression right here is the GCF, or greatest common factor. And then this part of the expression is factor number 2, we'll call it. So it's just another factor. So this is leading into a type of factoring that we're going to do called factoring by factoring out the greatest common factor. So in example 2, it says 10ab plus 5a. Our first job is to find the greatest common factor. So we want to look at 10 and 5 and think of the greatest common factor between 10 and 5. That would be 5. And then we want to look at the variables and see the greatest common variable there. They have a to the first power in common. There's a b in 10ab, but not in the 5a, so that can't count as a common factor. So 5a is going to be my GCF. Now, when I go to start to factor this, remember when we're doing this, it's going to look like distributive property when we're done. If you go back up and look at our example, I like to think of factoring using the GCF as undoing the distributive property. So when you find your GCF, that is the number that we're going to write that will be outside parentheses. Now, to find out what goes inside parentheses, we're going to take each term of our binomial there, 10ab, and we're going to divide it by the greatest common factor. So plus 5a and divide by the greatest common factor. 10ab divided by 5a. Well, 10 divided by 5 is 2. The a's will cancel and we'll have b. And then 5a divided by 5a would be 1, so positive 1. Now this expression goes inside these parentheses. So we do 2b plus 1, and we close our parentheses. And this is my answer. That is 10ab plus 5a factored using the GCF. Now, if you'd like to check yourself or you want to look at this geometrically, you can do that. So just for this one, I'll show you that you also could have looked at it like this, using what we've done in the opening exercise in example 1. Think of the greatest common factor and put it here. You know this has to be 10ab, and this has to be positive 5a. And then you can work your way through and think, okay, what would go here and what would go here? So you'd still get the same response. You'd get 2b, and you'd get 1, and you'd still have the same thing inside. Now, you can also check this by using the distributive property. which means you can do that by using the arrows or using the boxes. The only other thing is you also have to make sure there's no other GCF inside the parentheses. If you don't take out the biggest thing, when you go to multiply it back through, it'll work, but it won't be the greatest common factor. So I would say check factor number 2, just to make sure that you really did pick out the largest thing. Okay, now let's look at example 3. You've got 3g to the third h minus 9g squared h plus 12h. So we're going to do the same process again. First thing I want to do is find the GCF. Go piece by piece. Looking at 3, 9, and 12, the greatest common factor number-wise would be a 3. Now, when I look at the variables they have in common, I see g cubed, g squared, but then 12h doesn't have a g. But I do see that all 3 terms have an h to the first. So that counts as part of my GCF as well. So now I know I'm going to put 3h outside of a set of parentheses. So now we're going to take the original 3g cubed h minus 9g squared h plus 12h, and we're going to divide every single piece by the GCF that we just found. So the 3's would cancel, the h's would cancel, and I would get g cubed. Negative 9, take the sign with it, divided by 3 would be negative 3. The h's would cancel, so I'd get g squared. And then the h's here would cancel, and 12 divided by 3 gives me 4. So remember, this is the factor that you're going to take and put inside the parentheses. So this would be the second factor. And same thing up here. Second factor. So I will take g cubed minus 3g squared plus 4 and put it inside my parentheses. And now there is my expression in factored form using the GCF. Now at this time, if your teacher has given you other practice to complete, you are done watching your video and you can go complete your other practice. However, if your teacher would like you to complete the practice in your notes, please go ahead right now and pause the video and try the practice questions on the next page, and then resume when you are ready to go over the answers. Okay, now that you've completed the practice, let's go over the answers. Now, I think you will notice right away that I did not go through all the same steps as we did in the examples. The examples have a lot of extra things written so that when you're trying these problems later on your own, you have nice examples with all the steps there to follow. However, once you get comfortable with the process, you do not need to show writing down the GCF and dividing each piece. But that is still what I did. So I'll kind of do it with the first one here. 12y squared minus 3y cubed. Well, the greatest common factor between 12 and 3 would be 3. And when I look at y squared and y cubed, what they have in common would be the smallest power of y, which is y squared. Then if I took 12y squared minus 3y cubed and I divided each piece by the GCF, y squared and y squared would cancel out, and 12 divided by 3 is 4, so there's that. And then here, you'd have negative 3 divided by 3, which is negative 1, and then y cubed over y squared is y to the first. You just don't need to write the 1 there, and that's how I got that. And then I continued that process through the rest of these. So number 2 should be 7r squared s times 3rs minus 2. Number 3 is 5x times 2x squared minus 1. In number 4, you should have 3a times 1 plus 2a plus 5a squared. In number 5, 5x times 3x squared minus x plus 5. Number 6, 3y cubed times 2x squared plus 3xy plus 6y squared. And then in number 7, it says if 18m minus 12m squared represents the area of a rectangle, what are the expressions that represent the dimensions of the rectangle? So that means they want you to find the length and the width. Now, I drew a diagram here, but essentially you're doing the same thing as you were doing in the above questions. You're taking 18m minus 12m squared, and you're factoring using the GCF. Looking at 18 and 12, I know that 6 is the greatest common factor, and the lower power of m is m. And then I divide everything. 18 divided by 6 is 3. M divided by m would cancel out. Negative 12 divided by 6 would be negative 2. M squared divided by M would just be M. So you're getting that answer whether you show your work like I did using the actual boxes, or if you just use factoring using the GCF like we've learned during the lesson. If you need to pause this video to check any answers and copy things down, please do so. Once you are done, you have completed your lesson on multiplying and factoring polynomial expressions, day 1.